Hey everyone. I'm sure some of you noticed when you're depositing money to your crypto exchange account, be it Coinbase, Binance, or any other, what you do first, and let me here just filter this out so we only see incoming transactions. So what you do first is on your when you logged into your exchange account, they give you this deposit address. It's like any other Ethereum wallet, and then they tell you to send your money, your ETH, to this address for it to be deposited to your exchange accounts, for it to show up there. And so you send the money, and maybe this is not the best example. Let's see if we can find a wallet that's relatively new and does not have much of a transaction history. Yeah, perfect. So you send the money, you send the ETH to your account deposit address, and then sometimes immediately, sometimes a few minutes or a few hours later, depending on the exchange, uh, that ETH will then be transferred to one of the main exchange accounts, and this is this is done in this way for a variety of reasons, for better accountability, for security. And so the exchanges, they have this. So Binance has like Binance 14, Binance 18. They're like this huge wallets that carry a bunch of ETH in them. And this is like their main wallets where they store the ETH or any other crypto. And I'm sure you understand that what happens here, it's not manual. Like there's no Binance employee just monitoring these wallets, thousands of them, and then submitting the transactions as soon as ETH arrives. So this is automated in some way. And in today's video, we're going to be building something similar and learning how you could uh, build a bot that watches a certain Ethereum wallet. And then as soon as any amount of ETH arrives in that wallet, it will take whatever maximum balance that can be sent, and then send it to your main vault address. Let's call it a vault. So we'll have a deposit address, and then we'll have a vault address, which in this case is Binance 14. But let's say you're building, let's say you're providing a service that accepts crypto as a payment. You would most likely implement something like this for your clients to pay you with crypto. So what we're gonna need is to download MetaMask first, and then we'll get some ETH from a Rinkaby faucet to to our to our to our wallet. Okay. Yes. All right. Now we'll set up a dumb MetaMask account. We'll create a new wallet. We'll set a password. Yeah. Okay. So this here will be our, this is going to be the wallet that we will be watching for incoming transactions. So this will be our deposit wallet. And then we also want to create a new one where we'll be sending all ETH that comes to the deposit wallets. So this one would be our vault wallet. Okay. Now, so we need some money on our deposit wallet. Well, or actually, let's create another one, which is going to be our secondary. So We're going to submit a transaction from our secondary wallet to our deposit wallet. And then as soon as ETH hits this wallet, it will automatically be withdrawn to our vault address. Okay. So we need some Ethereum, some Rinkeby Ethereum on our secondary wallet to be able to do that. And for that, we'll be using one of the faucets here. So let's copy our wallet address. This one is from Alchemy. If this one doesn't work, there's also one from Chainlink. So just try either of them. Both of them send you 0.1 ETH per request. So if I click send me ETH, it will I just created this wallet, so this is weird. But let's try this one. Like I said, sometimes they work, sometimes they don't. MetaMask, secondary, okay. I actually forgot to change the network. So to be able to switch between test networks, you need to toggle it in your settings. So show test networks has to be on. And then after that, you will be able to switch your network from mainnet to Rinkeby. And once you do that, you should be able to see this page where we don't need any link. We only need ETH. And then it'll ask you to do this CAPTCHA. Okay. And then you just click send request. And as soon as this transaction confirms, you should see your Ethereum in this wallet, the one that you connected to this website. Okay, this should take a bit. Okay, there we go. So we now have our secondary wallet funded, and we can dive right into the implementation of our bot. Now, to be able to, for our bot to be able to communicate with the blockchain, so to listen on incoming transactions and also to submit transactions, we need a way to connect to an Ethereum node. The most straightforward way to do that is to use Infura. They provide you an endpoint URL. You can sign up for free. Once you sign up, you'll be able to create a project. You can create a new project, and then if you click on the project settings, you'll see your mainnet endpoint URL. We're not using mainnet now, so we just need to switch it to Rinkeby here, and then we can just copy it later and paste it into our environment variables. Now let's start. Let's start with this. It'll give us our package JSON. Right off the bat, we're gonna need ethers and .env. So let's install those. And then we'll just have our index.js. And also we need a .env file. Okay. So let's put our Infura ID in our environment variables. So we're not going to need the entire URL. We only need this project ID here. So just copy and paste it. And then another thing that we need here is we're going to need the private key to our deposit wallet. So for the bot to be able to submit transactions on behalf of our deposit wallet, it has to know its private key, right? So in MetaMask, you can get your wallet's private key by clicking on account details and then export private key. And after you type in your MetaMask password, after you type in the correct password, you'll be able to see your private key. You can copy that and then you can paste it into your environment, into your .env file. Deposit, wallet, private key. So we have our deposit private key, our deposit wallet's private key. So let's open our index.js. Let's make sure we load our environment variables using .env. .env config. And then let's load ethers. And we're also going to need a few utility libraries from ethers. Now, first thing first, we need to initialize a provider object that talks to the Ethereum node. So we need, because we'll be listening on the incoming transactions in real time, instead of using the HTTP endpoint, we'll be using the secure WebSocket endpoint, which means that instead of polling the blockchain, this will just open one connection, and then it will just keep listening on incoming transactions from the node. So let's initialize our provider as ethers provider WebSocket provider, and then we're going to need this part of the URL concatenated with our Infura ID from our environment variables. And then the second argument here is the network, which is Rinkeby in our case. Now that we have our provider, let's also initialize the deposit wallet, which is going to be an instance of ethers.wallet class. So we'll just be, it needs our private key and a provider instance that we created earlier. So we need to pass in our process.env deposit wallet and our provider. Okay. Now let's create our main function. It's going to be an async function. And so here, let's get our deposit wallet address. And let's console log that we're watching okay. Now let's try running this to make sure that everything's working so far. Okay. So if we do node index.js, we get an error. So WebSocket provider undefined because it's ethers providers. Let's do it again. All right. So it successfully derived the first wallet address, or actually the wallet address from our deposit wallet's private key here. And you can see that this matches the one that we have in MetaMask, 7cc9, 7cc9. And now, next thing we're going to do is we will be using our WebSocket connection and listening on any pending transactions in the pool. And we'll get a transaction hash for any transaction that has been submitted. And to illustrate better what I mean here, let's console log our transaction hash. And then so you can see it'll just dumping a bunch of transaction hashes, but this is not really useful. So we need to get more details about each transaction. Specifically, we need to know the address that it was sent from and then the address that it was sent to. And that way we can filter only and get only those transactions that sent ETH to our deposit wallet here. So to do that, we need to use the transaction hash and get some more details about the transaction. So we can do try catch here. Just pass in that error. And now we can use our provider and to get the transaction by the hash. And then we'll get the transaction object. And here we want to grab the from, to, and also the amount of ETH that is being sent from our transaction. And if 2 is our deposit wallet address, then we want to say receiving from this address. So let's also console log our transaction. Okay. Now when we run it, and then when we, and it is null. Sometimes what the WebSocket will send over, instead of a transaction object, it will just send null, and you can just add a check on top so that it just ignores them. Okay. Not here, here. All right. And you can see that this is a transaction object that we get as a result of calling this function here. So we'll have our from address, the to address, the value of the transaction, we'll get the nonce, some other data, and these transactions have not been confirmed, they're still pending. So what we need to do is we need to wait for it to confirm so that it actually happens, and then we'll have the ETH available in our deposit wallet. And what we're going to do is we'll also we'll add this configuration option where you can specify for how many block confirmations you want your bot to wait before it sends the ETH from your deposit wallet to your vault. Let's start by waiting for, so we'll add a configuration option here. We can actually add it to our .env, which is confirmations before withdrawal. And we'll wait for, let's wait for 2 blocks so that it's just faster. Okay, now we want to wait for, and the wait function from Ethers gives us handy API for waiting for a given number of blocks before doing anything else. So here we'll just pass our process.env confirmations before withdrawal, and then we want to, when we receive our transaction, and also if it fails, okay. So here we want to grab the balance of our withdrawal wallet. So we get our current balance. And then Here we want to specify the block tag for the latest block. Now, next what we need is we need the current gas price. Instead of specifying that manually, let's just grab whatever current gas is by using ethers. So it will be gas price and GUI, or let's just do gas price. And then I think it's the provider get gas price. Yep. And then our gas limit is for sending ETH. The gas limit is 21,000. So we can just hard code it here. So our maximum gas fee to be paid is going to be a big number from our gas limit and then multiplied by our gas price. Okay, so now we have everything we need to create a transaction object and then to submit it to our node. We'll be sending it to our vault address, and we actually need to add it to our environment variables. Vault wallet address. Copy it here. And then it will be sent from our deposit wallet address. We'll have a nonce. We'll just use this handy method from ethers. We'll get the latest transaction. We'll get the total count of transactions, which in most of the cases is the nonce. It is the nonce that you need to use for sending the next transaction. And then we'll have our value. So the value here is going to be, we still need to spend some ETH for gas, right? We can't just send everything. The transaction is going to run out of gas, and or it will just throw an insufficient funds error. So we need to grab whatever our balance is and then subtract the gas, the maximum gas fee that we will pay for this. And that will be the available balance that we can then send to our vault wallet. Next, we need to set the chain ID, which is 4 for Rinkapi. In case you're using mainnet, this will be 1. And then after, we should set our gas configuration, which is going to be our gas price and our gas limit. Okay, and we pretty much have our transaction ready to send. Now, what we need to do next is we need to submit this transaction object. We basically need to sign this with our deposit wallet. So we do send transaction, which is going to sign the transaction object and then broadcast it to the node. And then upon receipt, and in case it fails, I want to show an error message. So we have the same thing here, and this was for receiving, and this is for withdrawing. Okay. And once we send that transaction, once we send that ETH to our vault, we want to log a message saying withdrew and this is going to be our current balance minus our gas fees, ETH to vault. Okay. Cool. And so this is pretty much it. So let's give this a try. So let's try again. Run our bot, watching for incoming transactions. Send. Next. Confirm. It sees the transaction and then it's going to wait for it to confirm. And then it sent whatever ETH that we already had in our deposit wallet to our vault. Now let's check Etherscan to confirm that. So this is our deposit wallet. It has 0 ETH in it. We can see it here. Etherscan probably did not, hasn't indexed the transaction yet, but if you wait a little bit and then refresh, it should show it there. And then our vault wallet, which now has 0.01 ETH, just came 34 seconds ago from our deposit wallet here, and this is our this is the withdrawal. Okay, so one thing I would like to add to our logging is we want to make sure that we also say that we're waiting for confirmations. And so we can always increase that number. We can set it to 5 and then see if that actually does work. Okay, again, send some ETH to our deposit wallet. Next, confirm. Receiving, waiting for 5 confirmations. And this should probably go, yeah, before the wait. That's okay. So if we look at our, well, Rinkeby Etherscan isn't as fast with indexing new transactions as the mainnet. So you might not necessarily see those transactions immediately, but yeah. So here's our transaction we received. We only had 2 block confirmations. And so if we keep refreshing the page, it should show. Let me do this like that. Yep. So after 5 confirmations, and this should update here in a bit, it withdrew Ethereum from our deposit wallet to the vault again. You can check that here. Again, takes time. This is our withdrawal transaction.